Good afternoon all. I hope I am audible. So first will run from the PowerPoint. We'll just discuss what this is, game theory is. Then we'll solve some problems. With that, we will wind up the syllabus. Okay. Now, do you have any idea what is all this about? The game theory is about. Do you have any idea what is this about? The game theory is about.
Probability.
Probability. Okay. Anything else? Any other answers?
So is it regarding to competitiveness in market? Basically strategy.
Okay, right. Okay. So game theory was developed for the purpose of analyzing competitive situations involving conflicting interest. Okay. So that is, or if I put it in another way, I can say that game theory is a decision making tool. Okay. Under conflicting situations arises. That is when there are one or more opponents. So for opponents, we normally call it as players. So based on the player one or based on your opponent player, what situation he is following. So how to change your situation so that who will get or how you will get the advantage or whether your opponent will have advantage. That is what you are discussing with the help of this technique called as game theory. Okay. So this is used normally when there is a conflicting situation arises. You have player 1 and player 2 is available, and player 1 and player 2 are playing based on certain game principles, and accordingly you are making a decision. Okay, so I'm just give you an introduction only to the game theory. More details about the game theory I will not go through it. So there are two models are available in the game theory. The first model is called as two-person. Okay, the first model that is called as a two-person, and the second is called as two-sum. Sorry, zero-sum, two-person and zero-sum game. Okay, so two-person and zero-sum. So this is one way of classifying the game theory. So two-person means if the number of players is 2, it is known as two-person game. And zero-sum game, the sum of points wants equal the sum of points lost. That is one player wins and at the expense of the other. Whatever the one person is gaining, the as points, the other is losing. So these are the two models normally you can see in the case of game theory. There are other ways also it is classified. So this is basically based on the number of players. Okay. So number of players. So a game with n competitors is called n person game. So we will restrict our study normally into the case of two-person zero-sum game. Okay. So this is the model, whatever we are going to see. So this is based on the basic classification, the number of players. So the number of players, we will take it as 2. So it is a two-person zero-sum game. Okay. Now, based on the nature of strategies. Okay. So based on the nature of strategies also, the game theories are classified as pure strategy and mixed strategy. Okay. So pure strategy and mixed strategy. So that is based on the strategies of you and your opponent. So pure strategy means that if in a game any player always select the same strategy what you are choosing, that is called as the pure strategy. Okay. And if the correspond and if the mixed strategy is something like your opponent is changing. Okay, your opponent is changing the strategy. Okay, So may not be the strategy which you are following. So such a game model that is called as mixed strategy game. Okay. So you will have always two options, either to go for a pure strategy or for a mixed strategy. Okay. A mixed strategy will be always advantage. Okay. Why? Why? Okay. The opponent keep on guessing. Okay. What you are going to play, how you are going to play, he has to guess. Okay. So mixed strategies games are always advantage since the opponent is always kept on guessing. And the next will be based on the nature of final outcome. So that is what we have seen over here as in the case of zero sum, etc. Okay, that is whatever the one is gaining, the other is losing. Whatever the point one is getting, the other is losing that much point. That is one player wins at the expense of the others. Okay, so this is what is the basic classification or the types of models or introduction about the game theory. Okay. Now, normally this again, just like whatever we have seen in the decision making, here the game theory also we will have a payoff matrix. Okay, we will have a payoff matrix. So the outcome resulting from the game, if represented in the form of a table, we call it as we can call it as payoff matrix. Okay, so I'll just for an example, yeah. So this is strategy. This is player X and this is player Y. So there are two strategies are available for both the person, strategy 1 and strategy 2. Player X also have two strategies, strategy 1 and strategy 2. Okay, so if so minus 3, so this is 2, this is 3. I'm just giving some values, minus 2, minus 1 and 1. Okay. So now this is a typical payoff matrix. Okay. So this is what is called as a typical payoff matrix. Now, what can you interpret from this payoff matrix? What all informations you can interpret from the playoff matrix? So there are two players are there. Okay. So two players. So two players, X and Y. Okay. And each player having two strategies. Okay. Each player has two strategies. Okay. Strategies 1 and 2. Each player. Okay. So elements such as minus 3, minus 2, okay, against the first row 2 and minus 1. Okay, now what is the meaning of this minus 3 is? What is the meaning of minus 3 is? That is if X is playing, okay, that is if X is playing strategy 1 and Y also follows the same strategy 1, then X loses minus 3 points that will be gained by the player Y. Okay, that will be gained by the player Y. So if X plays strategy 1 and Y plays strategy 2, okay, Y gains 2 points, X loses 2 points. And sorry, this is 1, 2, and 3. Sorry, I made a mistake. So this is 2 and this is 3. Yeah. Now each player has not two strategies here, so that's a wrong. So player X has 3 strategies and Y having 2. Okay, that's the meaning. So if X player plays a strategy 2 and Y adopts strategy 1, then X gains 2 points, Y loses 1 point. So that is the information what you can get it from this payoff matrix. So this is basically called as the payoff matrix. So from this matrix, what is advantage, what is gaining, okay, these all informations you are able to obtain. Okay, so the payoff of each combination of strategies of the player is placed as element within the matrix. A positive entry indicates gain, okay, while a negative entry indicates loss to X. Okay, so negative entry indicates loss to X and positive indicates your gain to X. Okay, so if I turn, I can just change this matrix also in the other way. So when I am changing whatever the plus is shown over here, so that will come as for Y. That is, it need not to be always player X always here. So I can write this matrix also for player Y. So player Y will have 2 strategies, 1 and 2. X will, so here the X will come. He will have 3 strategies, 1, 2 and 3. Okay. So since if the player 1 is selecting, this comes as -3 here, that becomes +3 here. Okay, and there's -2. Yeah, so there's -2, that becomes 2 here. So this 2 becomes -2 in this case, -1 becomes 1. So this 3 becomes -3 and this 2 and 2 and 3 combination. So that gives -1. So this is how with respect to the player, you can write the corresponding payoff matrix. Okay, either this is right or this both are right. Depends on what player you want to write. You can remodify the matrix. Okay. So pure strategy, this is already I told you 2 strategies, pure strategy and mixed strategy. So simplest type of game is one where the big strategy for both the players are pure strategy. So this is the case if and only if payoff matrix contains a saddle point. Okay. So now from there are terms will be coming. That is called saddle point. Okay, then value of the game. Okay, then the criterions, the optimum criterions for finding the solutions. Okay, so there are terms are there. So there are terms are there, and these terms normally falls under to the categories of mini-max and maxi-min principle. Okay, so that is mini-max and maxi-min principle. So I have limited our game to 2% zero sum game. 2% zero sum game. So mini max or maxi min principle. Okay. So you know what is mini max and you know what is maxi min. So mini element and maximum element selected for each column is called mini max. We have already seen. Okay. Now the next term is called saddle point. What is saddle point? So point is a point. Okay, it's a point in payoff matrix. A point in pair of metrics where the maximum of row minima were the maximum of row minima coincides with the minimum of column maxima. Okay, so there are two terms are there. You can see over here. Okay, to get a saddle point, maximum of row minima. Okay, maximum of row minima has to coincide with minimum of column maxima. So row minima you have to determine. From that you have to determine the maximum. Okay, you have to determine the maximum, and from the another one, minimum of column maxima you have to select, and from that the column maxima you have to select, and from that you can select the minimum value. If both are same, okay, if both are same, then a saddle point existing for the game. That is, okay, so I'll just give you a matrix for you to illustrate this. So player A, and I have player B. So it is 5 minus 3 and 2. This is 2 minus 3 and 6. So minus 6. This is minus 2, 4 and 8. So what are the two terms you have to determine? Row minimum. Row minimum and column maximum. Okay. So column maximum, first column maximum is 5. Here the maximum is 4. Here the maximum is 8. Row minimum, you have the minimum value as minus 3. Here it is minus, and here it is minus 2. Okay, so row minimum you have to select, and from that you have to select the maximum. Okay, the maximum you have to select. So maximum is minus 2. Okay, the maximum is minus 2. So what is this approach? So what is this approach? Which approach are we following? That is maxi min. Am I right? Maxi min approach we are following. Okay, for the row operation and for the column operation. For the column operation. For the column operation, we are following which approach? We are following minimax approach. Okay. For column maximum, we are following the minimax approach. Okay. Now 4 and -2, are they same? Four and -2, are they same? No, they are not same. Am I right? So they are not same. When they are not same, what happens? What happens? No saddle point. Okay, no saddle point. Why there is no saddle point? Since the row, the maximum of the row minima and minimum of column maxima are not same. Okay, if they are same, then only the saddle point will comes into the picture. Okay, then only the saddle point will comes into the picture. So how to determine the saddle point? Okay, I'll just give you a question so we can so same way easily we can see. So this is player A, 1, 2, and 3. And this is player B. He is also having 1, 2, and 3 strategies. So -3, 40, -3, -4, -5, -4. Here it is -5, 16, and 70. So same approach, there is no approach is not going to change. Okay, approach is not going to. So select minimum of each. So step 1. So easily to select the minimum of each row. Minimum of each row. Circle it. Okay. So what is the minimum first row? Minimum in the first row is minus. Second minimum is, yeah, here also -3 is there. Second row, it is -5. Third row, that's not 17, that's -7. Okay, sorry. Okay, right. So I have selected the minimum of each row and I have circled it. Okay, so -3, -5, and -7. So as a next step, what I'm supposed to do is that I can take the maximum of each column. Okay, maximum of each column. And put it inside a square and enclose it in a square. Okay, so the first case, the first column. So first column, the maximum of first column. Yeah, so that is -3. Second column, which is the maximum. Maximum is 16. Third column, the maximum. Now, so I done it. Now, what is the situation is? Is there any saddle point is existing? Is there any saddle point is existing? Yes, since okay, the minimum of each row and maximum of each column has satisfied in two cells. So in this case, this game, okay, so this game will have two saddle points. Will have two saddle points, 1, 1 and 1, 3. Am I right? And 1, 3. So the best strategy, okay, the best strategy for player A is okay. So for the player A is 1. Okay, and the best strategy for player B is 1 and 3. Okay, so this is the information what you get term called, and the final will be the value of the game. Okay, the value of, so the value of game will be wonderful point value you are getting, that is called my. Okay, so that this is how you are finding the saddle point, and you are finding the value of the game. You are finding which strategy is best for you, which strategy is best for your opponent. Okay, these all are the information what you are calculating from the or identifying from the game theory. Okay, so we are finding the things from the payoff metrics. So payoff metrics will gives you the information about the strategies, how many players are there, what all strategies are available for each player. If each player is choosing which strategy, what if the opponent chooses the mixed strategy or the pure strategy, what is going to be its output. These are all things you are calculating from the game theory. The first part, that is a problem is having a saddle point, and from the saddle point you are determining the value of the game. Now in the previous problem we have seen there is no saddle point happens. If there is no saddle point is there, how will you proceed? Okay, so that is the next part. So solution of a 2 cross 2 game with no saddle point. So what can you do? That is the question. If there is no saddle point, how will you solve the problem? So in that case, you have to go for a method. Okay. If there is no saddle point, so first you have to, whatever the problem is, you have to check whether the saddle point is existing or not. If saddle point exists, then solve the problem like this. If that is not applicable, then you have to go for the next method that is called arithmetic method. So I'll solve a problem directly so that it will be easy for you to understand and also to get the results. So there are two players are there. So player A and player B. Each player is having two strategies, 7 and 4 for the player for the first row. Then you will have 5 and 6 for the second row. Okay, so apply first and see to it whether you have any saddle point here or not. Okay, none of the elements in the matrix are same, so you can ensure that however you are taking the row minima or column minima or maxima, etc., will not is going to be stop on the same point. They are going to divert. So there is no saddle point for this particular game. So in a you can able. So if that is the case, how to proceed? So no saddle point. So how to proceed? So step one, what you have to do is that you have to find the row. Okay, step one, you have to find the row difference. So what is the row difference? So 7 minus 4. 7 minus 4 is 3. And 6 minus 5 is 1. And I will have a total of, so total is 3 plus 1, 4. Okay, step 2, find ratio. So ratio here is 3 by 4 and next ratio is 1 by 4. Okay. Step 3 is to interchange the ratio. Interchange the ratio means keep 1/4 to top and 3/4 to bottom. Right. Now, same way, perform the operation for column. Okay. So find column difference. So column difference is 7 minus 5, it is 2. B is 6 minus 4, that is 2. Okay, and if you total it, you will get the value as 4. If you check the ratio, so ratio is 2/4. That is okay. I'll write it as 2/4, and this is also 2/4. Step 3, again interchange ratio. So I think this is the problem what we were trying to solve in the morning. And I told you that this is since there is no saddle point is available for this problem, we have to solve this problem. So if there is no saddle point, it means that you and your opponent are playing with a mixed strategy game, not the same strategy. You are changing the strategy, and as a result, there is no specific saddle point is not falling into this problem. So in that case, what you have to do is that you have to go for the step 1. You have to find the row difference. Okay, you can total it. So total by that corresponding difference, that is the ratio. You interchange the ratio, interchange between your ideas. Okay, same way column difference also you can determine, ratio you can find, you have to interchange the ratio, and this is only possible for the case of a 2/2 matrix. Okay, so so only equal rows and equal column. If it is a only 2/2 matrix only, you have to also try to solve by using this method. So now what are the optimal strategies? Okay, what are the optimal strategies? So what are we getting from these results? So optimal strategies for of player A is, okay, of player A will be 1/4 and 3/4, and similarly for the player B, it will be 1/2 and 1/2. That is what we are getting from the ratios. Okay, whatever we are getting from the interchange ratios, that we are selecting it. Okay, so once you got the strategies for both the players, you have to find the value of the game. Okay, you have to find the value of the game. So to find the value of the game, okay, so you can use the equation. So it is value of the game is A1V. So A1 into V. So that is A11 into X plus A21 into 1 minus X. So A11 here, the value is the first one. So A11. So A11 is 7. So 7 into X value. So X value is the first ratio, that is for player A. So that is 1 by, yeah, so the 7 into 1/4 plus A21 is 4. Sorry, it is 5. So 7 and 5, yeah. So that is 5. So 5 into the ratio, we got it as 3/4. or you can see it is 1 minus 1 by 4. Okay, 1 minus 1 by 4, and the value of the game will be 5.5. Okay, so that is how we are finding the value of the game. Okay, calculate. So to gain to a as expected the value of payoff. Yeah, so that is the way we are calculating the value of the game. Okay, is that part clear? Is that part clear? How we are finding the value of the game if no saddle point exists? Now, suppose if the matrix is not 2 by 2, say for example, it is 3 by 3. Okay, so how can you solve such problems? How can you solve such problems if the matrix is of size rather than 2 by 2? Okay, so this is what we have seen, 2%, zero sum. Then we have seen the pure strategies. Okay, so yeah, so the way in which we are finding. Okay, so the minimax and maximum, we already tried this. So we got the saddle point and we got the value of the game. We already solved. Okay, so mixed strategy also we have discussed. We'll come to in the details later. This is what I have solved you right now, algebraic method or arithmetic method. So used to solve the mixed strategy game. So mixed strategy games, normally there will not be no saddle point. So when there is no saddle point, there will not be, you will not be able to find the value of the game. So you are finding the solutions. Yeah, so value of the game, we have find it out the same. Okay, so 2, 1. Is this what we have solved? No, yeah. So 2. There is another problem is also the 2 minus 1 minus 1 1. Okay, so is there any saddle point? Is there? No. So you are finding out. So 3 by 5 and 3 by 5. So the same way you are finding the row difference. So first we are finding. So what we have find? We first find the row difference. Am I right? So what is the row difference? Row difference. So 2 minus minus 1. So that value will be 3. Am I right? Am I not audible?
Yes, sir, you're audible, sir.
Yeah. Okay, then tell me the row difference.
3, sir, for first.
Yeah.
For second, it is 2.
It is 2. So totally it is 5. So the ratio will be, 3 by 5 and it will be 2 by 5. So if I interchange it here, I will get this as 2 by 5 and this is 3 by 5. Now get me the column difference. What is the column difference?
It is 3 and 2, sir.
Again it is 3 and 2, so that is again 5. So again the game is it is 3 by 5 here and it is 2 by 5. So the ratio and interchange
2 by 5 and 3 by 5.
Yeah, it will be 2 by 5 and 3 by 5. Okay, so the strategies for player A is 2 by 5 and 3 by 5, and similarly for player B it will be 2 by 5 and 3 by 5, and value of game will be, so 2 into 2 by 5. Okay, so 2 into 2 by 5 plus minus 1 into 3 by 5. And what will be the value?
1 by 5.
Yeah, value will be 1 by 5. So that is solved over here. Okay, we are getting the value of game as 1 by 5. Okay, so this is how the arithmetic model is solved. So this is applicable only in the case when a matrix is of the size of 2 by 2. Rather than any size of higher order sizes of 2 by 2 matrix, okay, you have to reduce that matrix into the form of 2 by 2 and see to it any saddle point or this arithmetic model can be applied to find the value of the game. Okay, and that methodology is normally called as dominance rule or dominance in game theory. Okay, so the principle of dominance, also known as dominance strategy or dominance method, states that if one strategy of a player dominates over the other strategy in all conditions, then the later strategy can be ignored. Okay, so whichever strategy is dominant over the other, we can consider that one and we can ignore the weak strategy. Okay, and can reduce any kind of higher order problems to a 2 by 2 and can solve it. So a strategy dominates over the other only if it is preferable over other in all conditions. The concept of dominance is especially useful for the evaluation of two-person zero-sum games where a saddle point does not exist. Okay, so if it is a 2 by 2, you can apply arithmetic. If it is not 2 by 2, you have to apply the rule of dominance and you have to try to solve it. Okay. So this is the way. If all the elements of a column, say I, are greater than or equal to the corresponding elements of any other column, say j, then ith column is dominated by the jth column and can be deleted from the matrix. Okay, not only a single element, the entire strategy values, if it is higher for a corresponding row or a corresponding column, if it is greater, completely greater than the other one can be avoided and you can use the top one. If all the elements of a row, say ith row, are less than or equal to the corresponding elements of any other row, say jth row, then ith row dominated by the jth row and can be deleted from the matrix. So this is the basic idea of applying the dominance rule. Okay, so we will solve a problem, then I will come to the presentation part. Later presentation part. Yeah, so I'll just give you a matrix. So this is player A is having 3 strategy, 1, 2 and 3. Okay, and this is of B, player B, again having 3 strategy, 1, 2 and 3. So the values here are 7, 6 and 3. This is -2, 2 and -3. This is 5, 9 and 7. Okay. Yeah. So tell me how to proceed. First find the
dominant column.
No. A problem like this, whatever is given, first you have to apply the condition of saddle point and see to it any saddle point is there or not. Okay, then only you have to try for all dominance, etc. So first we have to find the row minimum. So the first row minimum is 3. Second row, the minimum is -3. The third row, the minimum is 5. Okay, now take the next thing. We'll take the column maxima. So column maxima, here the maximum is 7. Here the second column, the maxima is 9. And third column, the maxima is 7. So no saddle point. Okay, so no saddle point. And matrix is of size 3 cross 3. So no arithmetic mean is also not possible to solve. So in that case, you can try for the dominance rule. Okay, try for dominance rule. Okay, so the idea of the dominance rule is to reduce the game to a 2 by 2 matrix. So okay, when a 2 by 2 matrix is obtained, you can solve it by using arithmetic mean and you can find the solution. Okay, so now tell how to proceed.
We can remove second row, sir.
Yeah, why?
Why? Because when compared to other two rows, all of them are less than.
Yeah, okay. So first row, if we are comparing the row 1, okay. Compare row 1 with row 2. Okay. Row 1 is dominated. Okay. So row 1 is dominated over row 2. Row 1 is dominated over row 2. Okay. All the elements are like that. So I can reduce the matrix. Okay. So matrix is reduced. So matrix is reduced as 7, 6, 3 and 5, 9 and 7. Okay. So row I have reduced. Now next thing I have to see column. Now next I need to see column. So between column 1 and 2, is there any dominance is there?
No, sir. Between 2 and 3, second one
Between
we can.
column 1 and 3, any dominance is there? 1 and 3.
No, sir.
So 1 to 2, no dominance. 1 to 3, also no dominance. Now between column 2 and 3.
Is there, sir?
Yeah, so column 2 is dominated over 3. Am I right? Column 2 is dominated over column 3. So which one will you select? 6, 9 or 3, 7?
We will remove 6, 9, sir.
We will remove 6, 9. Okay. So we have to select the lowest one in the column wise strategies. So now your new matrix will be 7, 5 and it will be 3, 7. Okay. Now what to do? Now what to do? Now matrix is reduced from a 3 by 3 to a 2 by 2.
No, row subtraction and
Yeah, before that, when it is reduced to a 2 by 2, again check for saddle point. That is important. Okay, check for saddle point. So the row minimum. So row minimum here is 3, and second row the minimum is 5, and maximum if we see The column maxima, it is 7. Okay, here also it is maxima is 7. So no saddle point. Okay, check for saddle point. So no saddle point. Don't miss this. No saddle point. So when no saddle point is there, okay, apply arithmetic mean. Okay. Apply arithmetic mean for solving. Arithmetic or algebraic mean for solving. So find the row difference. So that is 7 and 3. This is 5 and 7. So the row difference is 4. Here it is 2. Column difference is 2. Column difference here is 5. So total this is 6 and this is 7. So the ratio will be 4 by 6 and the ratio will be 2
Sir,
by 6.
4,
Yes,
sir.
please.
4, sir. Column difference 2 and 4, sir.
Column difference.
7 minus 3, 4, right, sir? Here.
Okay. So 7 minus 3, that is 4. Yes, sorry. So that is also 4. So this is also 6. So 2 by 6 and 2 by 6 and 4 by 6. So if I interchange the ratio, this will be, yeah, so this will be 2 by 6s, 2 by 6s, 1 by 3, and this is 2 by 3. Here also the ratios will be, so 4 by 6 is 1 by 3 and this is 2 by 3. You can interchange it. And value for game equals 7 into 1 by 3 plus 5 into 2 by 3. How much?
17 by 3.
17 by 3. Okay, so this is the simplest way for finding it. You can solve it. There are straight away equations are also there to solve it. Okay, so I haven't gone through such equations. I don't want you to get more confused into it. So simple way you'll try to solve it. That's why I haven't touched the equations. So equations, if you want, you can refer the PowerPoint. So in the PowerPoint, the equations are given over here. You can see over here, these all are taken from the equations. Okay. Sorry.
Sir, any particular reason, sir, for considering the first column only for calculating value?
Whichever is likely to us, that is only we are calculating. Okay, that is what only we are calculating. You try to see it with respect to the column also. You have to end up in the same answer. Okay. We are talking about the strategy which is best to player A. With respect to player A, I am calculating, not with respect to player B. That is why I am selecting it like that. Okay.
Yes, sir.
Yeah, right. So some problems or some more problems are there is given over here. using the dominance property and dominance theory. Okay. So is that part is clear? Now I'll give you a different problem. One more problem I'll give. So it is something like I had again two players A and B. So A is 3-1 first strategy 2-7 and it is 1-11. This is the matrix. Yeah, tell me how to proceed. So first check for, so step 1, what is the step 1?
Saddle point there or not?
Yeah, check for saddle. Is there any saddle is there?
No, sir.
Minimum here is 1, here is 2, here it is 1. Okay, maxima, column maxima is 3 here and it is 11 here. Okay, so no saddle. Now what is the next one? Step 2. Step 2. Check for dominance. So it's not 2 by 2. So arithmetic is not possible. Check for dominance. Yeah, you see 3, 2, 1,
No
1,
dominance,
7, 11. No dominance. So how to solve?
Comparative dominance. Like, where there is
No
gap, so much gap.
dominance. Yeah, so if there is no dominance, there is a methodology is there to solve that is called sub-game method. Okay, that is called sub-game method. If no dominance, if no saddle point, then the method for solving the problem, okay, so that is basically called the sub-game method. So the procedure is something like that. Break the matrix into a number of smaller. Okay. So the subgame method, the procedure is break it into a number of smaller 2 by 2 cross 2 games, 2 cross 2 games, and solve each independently. And solve each independently. Okay. And select a sub game. So after that, select a sub game which optimizes the gains of the player, gains of the player playing more than 2 strategies. Okay. And finally, verify the selected. Verify the selected subgame for optimality. Okay, so that is a procedure. Yeah, so in this case, what can be done? So I can reduce this into a 3 metrics each. Okay, I can reduce by break into a smaller 2 by 2 matrix. So first is 3 1 and next is 2 7. So it is a 2 by 2 matrix. Then the second matrix is 2 7 and 1 11. Okay, and the third matrix is 3 1 and 1 11. Yeah, so 3 metrics I have made, which includes all the values. So this is called subgame. Okay, this is called subgame. Now find the value of each subgame. Okay, now find the value of each subgame. So if you then check for value for sub game, you check again, check for saddle point. Okay. Check saddle.
For first one, no saddle point, sir.
Yeah.
Arithmetic we should do.
If no saddle point, apply arithmetic mean.
So second matrix has saddle, sir.
Yeah, correct. Arithmetic mean. Okay. So what is the value for first sub game? I am not solving it. You can try. So value for first sub game will be 2.71. Second, saddle exists. So value for sub game, which is the saddle point?
So 2, sir.
2.
For second
So
one.
value for second sub game is 2. Value for third sub game, I think the value is 2.67. Yes, 2.67. Okay, so now from the value of the sub games, the largest value is 2.71. Okay, largest value is 2.71. So that you can take it as the optimal value. Okay, that you can take it as the optimal value. And strategies for player, you will have the ratios. Okay, you will have the row and column ratio. From row and column ratio, you can determine the strategies. Okay. And once after solving it, you have to check it for, okay, you have to check it for optimality. So how will you check for the optimality? So checking optimality. So I had my first row as 3x1 plus 2x2 plus x3. Okay, 1x3. So first I will check in the column wise, then I'll go in the row wise. Okay, so all the thing I have to check. So 3x1 plus 2x2 plus x3. Okay, should be greater than or equal to v. So v is value of gain. V is value of gain. So the second row is second, you can see the data here. So the second equation will be x1 x1 plus 7x2 plus 11x3 should be greater than or equal to v. Now select it as y. So 3y1 plus y2 greater than or equal to v. Okay, so 2y1 plus 7y2 greater than or equal to v. Then y3 plus 11, sorry. So y1 plus 11 y2 greater than or equal to v. Okay, where do we get the values of x1, x2, x3? x1, x2, x3, y1 and y2. You will get it from the ratios. Okay, you will get it from the ratios. You will get it from the ratio, row and column ratio. So x1 value is 5 by 7. x2 is 2 by 7. No x3, so value is 0. So y1 is 6 by 7 and y2 is 1 by 7. You can substitute in all the cases. Okay, and everything will satisfy. Okay, all has to satisfy. Okay, all has to satisfy. So this is how we are finding the value of the gain if the dominance is also not applicable. So I will stop here. We will have our last class on tomorrow. So I will discuss the solution of these problems, how to solve it graphically. Okay, how to solve this graphically on tomorrow's class. So with that, I will wind up your class. Any doubt or anything to be clear, we will discuss right now. Anything is not clear, we will discuss or else we will wind up. Now 4-5 questions are pending. So I will tell you tomorrow or tomorrow night or day after tomorrow night that I am going to switch it on. So anything to be discussed, we will discuss. So that will be the last topic, graphical method in game theory. Any doubt to be discussed, we will discuss or else we will wind up. Discussing about the game theory, and in the game theory, the last type of problem fires the solution is graphical method. So applying the graphical method, we can solve a 2 cross n or n cross 2 sub games or games to find the decision point. Okay, that is in any one of the axes, that is either a player A or player B should have only two strategies Okay, the other side, more number of strategies. If they had also, we can solve by using the graphical technique. So we will solve a problem so that you will get a clear idea in this regard. Okay, so this is where we have stopped. So I will first take a 2 cross n. Okay, so I'll take a 2 cross n problem to solve graphically. So if a 2 cross problem, so player A, how many strategies will we have?
Two.
Yeah, player A will have only 2 strategies, 1 and 2, and player B can have n strategies. So for our SNS, I am taking 3, 1, 2, and 3. So the strategy values are 2, 4, and 10. Here it is 9, 6, and 3. Okay, so that is the problem. Yeah. So you can divide, you can check for the saddle points, you can check for the dominance. Okay, so you can check for the sub games, the method of sub games. All these things are possible here. So I'm not going into any of those things. So we will straight away we'll see how to solve this graphically. So the values are 2 and 9, 4 and 6, and 10 and 3. So that is what is basically I am going to take or plot in the graphs. So I will mark the values. So it is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Here also 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. That is sufficient. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Since I have the maximum value up to 10, I am marking only up to the point number 10. Okay. So graphs on the top axis, it can still go further. Okay. So this graph will be again limiting to the search space up to 10. Okay. Okay, now select the first set of value. Okay, so the first set of value is going. So player 1 strategy 1 and player 2. Okay, player 1 it's both strategy and player B it's a 2 strategy. So 2 and 9. So I'll take 2 on one side. So I'll mark the 2 here on one side and I will mark the 9 on the other side. So 2 cross 9. Okay, and I can connect it by using a straight line. So that is the first line. So L1 corresponds to my decision. Corresponds to my decision. 2 for the player A and 9 for the player. Sorry, player A strategy 2. So 1 and 2 that is covered. Now we'll take the next strategy. Okay. So the next strategy is 4 and 6. Okay, so here it is 4 is available. Here it is the 6 value is coming. Okay, so 4 and 6 I will again join with the help of a straight line. So that is basically L2. Okay, so this is L2 coordinate. This is L1 coordinate. Okay, now the third one. Okay, now the third one. So the third one is this one, 10 and 3. So this is L3. So 10 on the strategy 1. So strategy 1 and strategy 2. That's the way I am just marking it like that. So if we see here, so this is strategy 110 and strategy 2 it is as 3. Okay. Yeah. So I will join that 2 as a straight line. So that is L3. So we can see all are now crossing with the help of the lines. Okay, now you have to select the feasible region. Okay, so the feasible region for this case that will be the shaded region. Okay, so this is the feasible solution region for the case of a 2 cross M problem. Okay, so this is the area which is bounded by the, okay, that is bounded by, this is the region which is bounded by all the 2 cross 3 strategies. Okay, so you will have points like P, Q and R. Okay, so you will have the points like P. Okay, so if I mark it, 1 minute. So this is the first point. Sorry. This is the first point P. Okay, and this is the intersection point Q, and this is R. Okay, but Q point anyhow you cannot select it because that is not a common point taken by all the 3. So P and R you have to consider. Okay. So P and R you have to consider. And what you have to do?
Sir, why not a Q, sir?
Pardon me?
Like why we should not take Q, sir?
Q, is it a common point cut by all the three? That I had now 3x2 strategies I have marked over there as 3 lines. Okay, is the Q point is covered by all the three? Since if the line is passing through that Q point, then it might have taken. Based on the shape right now, the Q is not a common one. It is showing this only as the bounded regions. Okay, that is why I'm not considering Q over there. So this is my feasible region. Okay, so this is my feasible region. So feasible region is not covering the point Q. So I am not taking the point Q over there. Yeah. So now, now what is the value of the game? We have to get the value of the game. So P or R. So whichever is the highest peak, okay, whichever is the highest peak covered in the feasible region, that is basically taken, okay, that is basically taken as the value of the game. Okay. So so here I have Q I eliminated since that is not covered by the feasible region. Okay, that is so though that is a P that is not covered in the feasible region, I ignored it. So P and R. Okay, so I add P and R. So which is the highest peak? P or R? Which is the highest peak? R is having the highest peak. Am I right?
Yes, sir.
So R is the highest peak and the corresponding R wherever it is touching, okay, the R wherever it is going to touch, okay, wherever it is going to touch, that is taken as the value of the gain. Okay, so here it is R, it will be touching over here. The value corresponds here will be 5.3. Okay, so highest peak is R. So therefore, the value of game is 5.3. So this is basically a problem of 2 cross n. Okay, so this is basically a problem of 2 cross n. So a 2 cross n problem, the highest peak you have to select. If I change the problem into a n cross 2, then the lowest peak your feasible region is going to change, and hence the solution wherever you are going to take the solution, that is also going to change. Okay, so this is how it for a 2 cross n problem we are taking the decision. Was it clear? You can check this problem mathematically also. Okay, you can check this or you can check this problem by using any of the possible methods also, and you can see are we getting the same result or not. Okay, so I think when we are solving with the help of methods of sub games, you will get the result as 16 by 3. Yeah, approximately 5.33 you will be getting. So graphical you can verify with the help of other solutions also. Okay, so that's the way also you can get a question. Okay, check, find the solution by graphically and check its appropriateness, something like that. You can expect a question. Okay, is this clear? Is this clear?
Yes, sir.
Yeah. So if this is clear, I will go to the other type, that is M cross 2. Okay. So how to solve an M cross 2 problem graphically. So here I had my player A. Here I will have player B. So how many strategies are possible for player A? How many strategies are possible for player A? Eh? N strategies are possible for the player A. Okay, and B will only have 2 strategies. For example, we'll take a similar type. I will say 1, 2, and 3 for player A, and player B has only 2, 1 and 2. The values are 4 and 2. I had 3 and 8. I had 2 and 12. So I have to make it. So I'll take this point. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, so here also 1, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Ten, 6, 8. Yeah, okay. So I can extend. So that is, so 12 is my maximum limit. So I'm taking it only up to 12. Okay. Now what is our first set of data to plot? It is 4 and 2 for player A. Its first strategy values 4 and 2. So 4 I will take it here, and 2 I will take it here. Okay, so I will join it. So that is taken as L1. Okay, now the next is 3 and 8. I will mark it as line 2. So this is 3 here, this is 8 here. Okay, so I will join 3 and 8 by using a straight line and will mark it as L2. Okay, now I'll go for the third one. So this is L3. L3 is 2 and 12. Okay, so L3 is 2 and 12. So 2 I will mark it on this side. So corresponding, please don't change your sides, and please don't mark. If you are doing like that, okay, your solution is going to be wrong. Okay, So please check the consistency in choosing the side. If this is taken as strategy 1, let it go for as a strategy 1. Let the side will be taken as strategy 2. Okay. So now this is strategy 1 and this is taken as strategy 2. Don't change the sides. If you change it, your solution space, everything is going to change and your result is going to vary. So that is the shape. So here in this case, this is going to be the feasible region. Okay, so the shaded region is your feasible region. So again, you will have points here. So this is going to be your P point. This is going to be your Q, the R point, and bottom one you have your Q point. So Q is not shared by the Q is not shared by the all the three constraint. Okay, only two constraint will fall only at 3. So again here now it is between P and R. Okay, P and R. So here in this case of n by 2, that will be the lowest point. Okay, that will be the lowest point. Is P is the lowest? Yeah.
Sir, a small doubt. Sir, why
Yes.
you are not selecting the feasible region to be the area covered by line L1, sir? That's the lowermost area, sir. Because that area is covered by even all the three lines, no, sir. L1, L2, and L3.
Which point, pa?
Sir, the line line L1, no, sir. Area covered by line L1.
Area covered
And line
by
and area covered by L3, sir. The bottommost area, sir.
Bottommost area. Okay, so that is the way in which we used to normally select in the case of case of an n by 2. So n by 2 it will be the top region and 2 by n it will be the bottom region. Okay, that is the way normally we are selecting it. So it will be done based on the functional values only.
Oh, so it's the convention, sir.
Yeah, that's a convention.
Oh, okay, sir.
Okay, so the lowest intersection point is a shaded area. Feasible region is the intersection of optimal rows that should be played by the player having to make choice among many rows. Okay, that is why we are selecting it.
Okay, sir.
So the lowest point here will be P and the corresponding P value . The corresponding P value, whatever you are taking here. Okay, so that will be taken as the value of the game. So that is basically 3.7. So value of the game is 3.7. So we are basically doing this in advantages of player A. That is the reason why we are selecting the areas as shown like this. Okay. So the other areas that will be favorable for the player B. Okay. So this is how we are solving the problem. I'll just quickly see any other description is given in the PowerPoint. So graphical method. So we have discussed. Okay. Yeah. So you see max/min equals 4. When you first we draw two parallel lines, 1 unit distance and scales. Okay. So any strategies on one side only, we are expecting it to be 3 strategies. The other side, we have the option to go for the vice versa condition. So the lowest value V in the shaded region indicates the value of the game. From the above figure, the value of the game is, so likewise we can draw a graph for player B also. Okay, so player B, if you are plotting, it should be the vice versa situation. Okay, so we are talking about player A. So strategy of A1, strategy of A2, strategy of, that's the way we are taking. So that's why we are taking the lowest point with respect to player A. So with respect to player B, strategy B only, we are basically drawing the line and value. We are taking the common point, which is minimum in the condition.